In this video, we're going to review the different types of triangles. So if you recall, we have scalene, isosceles, and equilateral triangles. So if I'm talking about classifying a triangle by its sides, this is where we'll use the words scalene, isosceles, and equilateral. So remember, a scalene triangle has no equal sides, isosceles has to have at least two, and then an equilateral has all three. So right here, these different classifications you must know. These are important, and hopefully they're a review for you. The next type of classification is if we talk about by angles. So if I'm classifying a triangle by angles, we'll notice now I don't use the word scalene, isosceles, and equilateral because those talk about the number of sides that are congruent. When I'm talking about angles, one way to classify is if it's acute. So if you have three acute angles, meaning all angles are less than 90. Equal angular is what it sounds like, so equal angles. So three angles where they're 60 degrees each. If a triangle is equal angular, so meaning if all three angles are equal, well, that's going to force all three sides to also be equal. So if a triangle is equal angular, it's also going to be equilateral. And if it's equilateral, well, that's going to force all three angles to be equal, which means it'll be equal angular as well. So those kind of go hand in hand. So if you have one, you have the other. But in terms of naming them by angles or by sides, you would use equal angular for angles, equilateral for sides. And then we have our right triangle, so exactly one right angle makes a right triangle. The other two angles have to be complementary, so to kind of illustrate what that means, if you have a right triangle, if this angle right here is 90, well, 180 degrees split between three angles. If one of them is 90, you take 180 and you subtract off this 90. That means that these two angles that are left also have to add to 90, which is why it says that those other angles have to be complementary. They have to add up to 90 because there's 180 degrees between all three angles. And then for an obtuse triangle, that means you have one obtuse angle. So one of the angles is bigger than 90 and the other two are acute. So that would be your obtuse triangle. So looking at focusing a little bit more with isosceles and equilateral, because those are the ones that really allow us to make conclusions, especially with isosceles. Equilateral, it's pretty much if the sides are equal, then all three angles are equal to 60. But when we talk about isosceles, we can do a little bit more with it. And then we'll start looking at some proofs with isosceles triangles and how we can use those to make conclusions. So the anatomy of an isosceles triangle, the side that is across from the two congruent legs, or the two congruent sides, this side right here is called the base. And this is across from what we call the vertex angle. So this angle right here is the vertex angle. So the base is always across from that vertex angle. And then the two congruent sides, those are called the legs. And across from those legs are congruent base angles. So these angles right here are our base angles. And the base angles are the ones that are always congruent. And they have to be across from the congruent sides, or they're across from the legs or opposite those legs, which is why they're congruent. So using that idea, let's go ahead and look at some of these examples. So these are both isosceles triangles because they both have two congruent sides, which means that the angles across from those sides also have to be congruent. So if I wanted to find what these missing angles are, I know that all three have to add up to 180. So there's a couple ways you can do this. You can set up an equation. You could put x in here, and you could say 26 plus x equals 180, and then just solve it. Or some people like to just say, okay, well, I'm going to take and I'm going to just work with the numbers instead of setting up an equation. So I could take 180, subtract off my 26, and I get 154, which means I have 154 degrees to split evenly between those two congruent base angles. So if I just divide that by 2, that's going to give me 77. So that means each of these values down here has to be 77. And that goes for, if you went to solve this, you would get the same answer. So either way is acceptable for work and for setting it up. So if we look at the next one, again, isosceles triangle. So this means the two angles across from those sides are congruent. So this time, instead of giving us the vertex angle, they're giving us a base angle. And remember, base angles are congruent. So that means that this is 53 as well. So if we take and we add up the 53s, that gives us 106. And that means we have 180 degrees total minus the 106. That's what we have left to split. Or we have left for the angle. I shouldn't say to split, but what we have left for this angle. So when I subtract those, I get 74. So this angle here has to be 74. So the vertex angle 74. Again, the other option would be to put an x here, and then you set up your equation. You could have said x plus 53 plus 53 equals 180. And in the end, you get the same answer. So both totally perfect options, whatever you think's easier. And then the last example, now we have a picture where we have multiple triangles. So when I look at this picture, I see 3 triangles. I see an obtuse triangle here, and I see an isosceles triangle, also a acute triangle. So if I classify this by angles, it's acute. If I classify it by sides, it's isosceles. And then this triangle over here, by angles, it's obtuse. By sides, it's isosceles. And then when you look at the big triangle, it looks as if maybe a right triangle, maybe acute. I don't really know exactly by looking at this. But then I also look at this by sides and say, okay, it's scalene because I don't have enough markings to represent anything else. So I see 3 triangles, and what I'm going to do is I have to find the measure of all the angles. So the first thing I look at is, where is there a number? There's a number right here. So I look at this triangle first, this obtuse triangle. And I see that it's isosceles. So right away, I'm going to go ahead and say, okay, well, the angles opposite those congruent sides have to be congruent. So that means this angle right here has to be 32. So then in order to find this angle at vertex D, I'm going to add up the 2 that they give me, the 32s. And then I'm going to go ahead and I'm going to subtract that from 180. So 180 minus 116, or minus 64. I did the subtraction already. Minus 64 gives me 116. So that means this angle right here is 116. So let me fill that in. And remember, you could have set up an equation. You could have said 32 plus x equals 180. Solve, you get the same thing. And then that's done, this triangle here, but now I have to figure out how can I get an angle inside of this triangle on the right side. So these 2 angles, remember what I was saying, I don't know if this is a 90-degree angle, I don't know if it's less than 90, I don't know if it's greater than 90, so I don't know what those add up to. However, on this side, I know that these 2 angles have to add up to 180 because they are supplementary, they form a straight line. So now what I can do, so this was for my first part. My second part, I have supplementary angles, so that means I could subtract off 116 from 180. And when I do that, I'm getting 64, which we already saw here because it's the same subtraction. So we get 64. And now I can look at this and say, okay, well, I have an isosceles triangle right here with 2 congruent base angles. So this has to be 64 as well. And then to figure out the last angle, well, now all 3 of those have to add up to 180. So now I can add my 2 64s. So we get 128, and then subtract that from 180. And we end up with 52. So this angle right here is 52. So there's my work. It's a set explain, or it would be a good idea to actually write out the explanations. Like if you were doing this on a test or quiz, I would recommend writing out why you're doing all of this, just to be able to get your partial credit. And then kind of exactly what I was saying as I was doing it, you would just be writing it out. So there you have it. Using isosceles triangles is probably going to be the most frequent thing you'll see with going and using the angles opposite those congruent sides to help you solve some problems. The other situation you would run into is maybe you have an equilateral triangle, so all equal sides, all angles have to be equal, which means they have to be 60. because 180 divided by 3 is 60. So go ahead and try the check your understanding problems using these different concepts.